In this video, we're going to be talking about piecewise functions. A function that is defined by more than one equation over a specific domain is called a piecewise function. They look strange, but those functions are very commonly used in real life. For example, you pay flat fee until you talk 200 minutes on your phone, and after 200 minutes you start paying 20 cents per minute or something like that. It is a common case. So let's see how to evaluate piecewise functions. Well, the piecewise functions domain is given after that if in the problem. So that's the domain of the function. It is said that x can be less than -4 value. It can be all the way from -infinity to -4. Then there are values between -4 and 4. And then x can be greater than 4, so this function may continue past 4 up to positive infinity. So it looks like the domain is going to be from -infinity to infinity of this function. And let's see what's happening. Well, for all the values before -4 included, so I'm going to make a straight line here. For -4 included, the function values are going to be 2. Between -4 and 4, -4 and 4 not included, the function values, the y values, are going to be absolute value of x. And past 4 included, the y values are going to be x plus 1. So when I'm asked about f of 4, my first job is to locate where 4 is. And 4 is right here, and the rule for 4 is included in this interval. So I'm gonna say then f of 4 is gonna use the rule x plus 1, and x is 4. So let's, so that's gonna be 4 plus 1, or the y value is 5. The next question, they ask me, what is f of -5? So I need to go ahead and find where -5 is, and -5 is right here. So it looks like the rule for -5 is the y value is equal to 2, because that's where my -5 stays. So f of -5 is going to be equal to 2. And I'm going to underline that here too. Then the last one, f of -1. So -1 is somewhere in between -4 and 4. So the rule for -1 is going to be absolute value of x. So f of -1 is going to be absolute value of that -1. And absolute value of -1 is 1. Let's do that again, and furthermore we're going to graph that piecewise definition, piecewise function. Well, how do we graph it? So again, we said that right here, this is the domain of the function, and what this domain says is before 2 not included, we're gonna graph y is equal to 4x minus 4. After 2 and x equal to 2, we're going to graph y is equal to -x plus 1. So we have 2 graphs to graph, and they would meet somewhere at 2. One of them is going to be graphed up to 2, and the next one is going to be graphed past 2. So how we graph? We usually pick up values. There is that method with one of the methods for graphing lines is through y-intercept form, y(mx plus b). We graph that b is the y-intercept. And we count slope to be whatever the slope is, it's going to be slope over 1. Go up that number or down that number if it's negative over 1, and that's going to be the slope. So that's one of the methods, very easy to graph. So for the problem y is equal to 4x minus 4, the y-intercept is the number negative 4. So this graph is gonna cross through negative 4. And the slope is the number up front of x, which is 4, so it's considered 4 over 1. That means I'm gonna go rise 4 over run 1. Rise over 1. So rise 4 over 1. What this mean? So I'm gonna go rise up for 1, rise for 1, and down, drop down for 1, and so on and so forth. I'm gonna graph it with a different color. Let's see that color right here. Notice that I stopped at 2 because this graph doesn't work past 2. Furthermore, 2 itself is not included, so I'm gonna have an empty dot at that place to show that the 2 is not included in the picture. I can apply the same method for the next graph. Here the y-intercept is going to be 1 and the slope would be negative 1 over 1, which means down 1 over 1. That's a little bit inconvenient because I'm gonna start from the y-axis, but remember the y-axis is not included. My graph is supposed to start from 2. So I'll just sketch it with dotted lines. So start from negative 1 and goes down 1, down 1, down 1, down 1, and so on and so forth. Well, since my graph starts from 2, I'm gonna actually only sketch past 2. These previous dots before 2, they helped me graph, but they're not included in the graph because this graph starts from 2. So I'm gonna erase them or ignore them. So this is how this function looks like. There is a jump between this function. Let's see what's the domain. As we said before, the domain is included after that if, and I can see that negative values are possible and positive values are possible and 2 is possible. There is a value at 2, so the domain is going to be all the numbers between negative infinity and infinity. Question about the range is a little bit different because there is no picture past 4. So it looks like the whole graph is up to 4. Furthermore, 4 is not included. So the range is going to be, and I know that some of you would think, well, that's 4 to negative infinity, but remember that's incorrect. We are supposed to start from the smallest value and go up. So I'm gonna say the range is from negative infinity up to 4, and 4 is not included, so I put parentheses. Similar question, graph the piecewise function, use the graph to determine the domain and the range. So again, the domain is given here. X can be less than 1, x can be between 1 and 3, x cannot continue past 3. So see how it looks. It goes from negative infinity to 1, and then it goes up to 3, but then it stops at 3. And between 1 and 3, 1 and 3 included, the rule is going to be 2x plus 1. And before 1, the rule is going to be x plus 2. And since it's not included, I have my graph a little bit curved. Okay, so that means before 1, I'm going to graph the line y is equal to x plus 2, which that has a slope of 1, 1 over 1, and y-intercept of 2. So y-intercept of 2, 1 up, 1 over, and I have to stop at 1, so I'll then go backwards, 1 down, 1 over, 1 backwards, 1 down, 1 backwards, and so on and so forth. So this picture would, and I'm gonna make a circle here at 1 because this 1 is not included. So here you go. Let's see the other part. So we've got y is equal to 2x plus 1. Again, the slope is going to be 2 or 2 over 1, and the y-intercept is equal to 1. So we have to start from 1 and go 2 up and 1 over. So start at 1, and go 1 and go 2 up, 1 over, 2 up, 1 over, 2 up, 1 over. So I'm gonna clean a little bit. So I'm gonna make it with different color just to see. So start it from here, but that's just a dot, not included in the picture, and then that one is already going to be included in the picture. So it's right here, and it looks like they overlapped. So that initial empty dot, that was empty dot, was overlapped with the second one, graph. So the graph is not supposed to be different colors. I just graphed it for you to see that those are two different pieces, but in fact, this graph is one whole thing. So that point that we thought was not included turns out to be part of the graph, and in fact, the graph is uninterrupted. So let's answer the question, what is the domain? Well, it looks like all the values from, wait a minute, I had ignored the fact that this graph ends at 3, so I should make a correction here. My graph goes up to 3, so I'm gonna have to stop at 3. Like that. And I used a full circle showing that the graph, that 3 is included in the picture. So what is the domain now? Well, the domain started from negative infinity, and we went negative 1, 1 wasn't a problem, we went all the way up to 3. So the domain is from negative 1 to 3. Let's see what's the range. And for range, again, we're going to look at the y-axis and see where do we see values. And those values down the y-axis going to continue to infinity, but up here it's gonna stop at that place, which is 7, I think. And this value is included because that full dot. So the range is start from negative infinity and go up to 7. graph each piecewise definition. Use the graph to determine the domain and the range. So exactly the same question. The difference here is there is a quadratic function. If we don't remember how to graph it, we may plot some points. So again, I'm looking at again in the domain of this function, and it looks like it starts from less than -1, so from negative infinity and goes up to -1, but there is between -1 and 1 another piece, and it stops there. And between -1 and 1 it is included, and that's the function is going to be x squared, and before -1 the graph is going to be negative x. So negative x. Okay. So first, how to graph y is equal to -x. Well, that's the same as, and of course we can plug some values, but that's very easy to think. The slope is -1 and the y-intercept start from 0 and go down 1, 1, 1. 1, 1, 1. The only thing is that we need to start go up to -1 to be precise. But of course, if that method doesn't work for you, you can always plug in x values, let's say -1, -2, and so on and so forth, and see what the y value is. So plug in -1, 1, so those points are not how I graph them. This would be right up there. Okay, and again, I'm allowed to graph up to 1, so I'm gonna have an empty circle at 1 and go up this way. Now, how to graph the parabola. So how to graph y is equal to x squared. Well, that's a parabola. It has a shape, so we need to plug in more values. What if x is -1? If x is 0, what if x is equal to 1? And -1 squared is 1, and 0 squared is 0, and 1 squared is 1. So pretty much those are the 3 points I'm gonna be using. And 1 is included and -1 is included. So the same as in the previous case, we have those 2 values included. And that's gonna be some curly shape here. And I didn't make it very well. Like it's not gonna be straight down, but kind of smooth shape. And that's what this graph is. Well, what's the domain? The domain is given to be from -infinity all the way up to 1. At 1 it finishes with including. And then for the range, I'm gonna look at the y values, which look like they're all over here. The lowest y value is 0, so the range is gonna be from 0 including up to +infinity. And I'm gonna stop here.